In this video, we are going to solve some problems on RC circuit. The figure shows a 10-volt battery connected in a circuit with two resistors and a parallel plate capacitor C and 3 ammeters. The circuit has been connected for a long time. What is the current reading in ammeter A3? So there are two things which we have to focus on. One, that the circuit had been connected for a long time, and then which current reading are they asking for? They're asking for A3, which is connected next to 100 ohms. Capacitor connected for a long time means capacitor will act like an open switch. So we can redraw the circuit, removing the capacitor and just drawing an open switch. So it means that to get the current, I want to use the formula V over R. Now V is 10 volt and the resistance will be 50 plus 100 because the current is now going to move from the battery through 50, through 100 and come back to the battery. So it is not going to go through the branch where there was capacitor. So the total resistance becomes 150. We can calculate the current as 0.067 ampere. Next problem, we have got an RC circuit. The first problem is asking us, the first question is asking us to get the time constant, which is easy. But note that initially the capacitor was uncharged and then the switch is closed at t equal to 0. So just remember how was the initial situation, so we know that which equation to use. For time constant, it does not matter because it's RC. We have R, which is 5 ohm. C is given as 10 microfarad. We have to convert that to farad, multiply by 10 to the power negative 6. And we get the answer as 50 times 10 to the power negative 6 seconds for time constant, which we can also write as 50 microsecond. Then it's asking what's the maximum charge on the capacitor after the switch is closed. Maximum charge, the formula is CV max. C is 10 times 10 to the power negative 6. V max is the battery voltage, which is 10 volt. And we can get the answer for Q max, which is 100 microcoulomb. Find the charge stored in capacitor 10 microseconds after the switch is closed. So now we have to use Qt equal Q max bracket 1 minus e to the power of negative t over tau, because it's asking us to find the charge at a particular time. Everything we know, all the numbers we know, only we have to find the charge at the given time. Q max we found, we'll substitute that number, which is 100 microcoulomb. 1 minus e to the power of negative t. T is 10 microseconds, so 10 times 10 to the power negative 6. And tau is 50 microseconds, so 50 times 10 to the power negative 6. We can solve it using the calculator and we can get the answer as 1.8 times 10 to the power negative 5 coulomb. Next problem, how long after the circuit is closed will it take to charge the capacitor to 90% of its maximum charge? So it's asking for time. It's also telling us the capacitor needs to be charged to 90% of its maximum charge. That means Q at a given time should be 90 over 100 times Q max, 90% of the maximum charge. That's the charging equation for capacitor. So we have got Qt, which is 90 over 100 times Q max. Q max we write as it is, bracket 1 minus e to the power of negative t. Time we don't know, it's unknown. But time constant is RC. R is given as 100. C is 150 microfarad. So we'll write it as 150 times 10 to the power negative 6. So our equation is ready. You can see that Q max on either side can be cancelled out. And then we can solve the equation using the calculator to find what's the time, which will come out as 0.0345 seconds. Okay, so in this problem, what's the most important part is to know how to substitute Qt into the equation. They said 90% of the maximum charge, so we just write it as 90 over 100 times Q max. And when you substitute that into the equation, we don't know what is Q max, but it gets cancelled out on both the sides. So it does not matter if we don't know what's Qmax because it's getting cancelled out. Okay, which we can also, so time we got it as 0.0345 seconds. We can convert that into milliseconds if required, which will be 34.5 milliseconds. Another problem, we have been given 3 circuits. The question is asking you find the time constant for each circuit. So for the first one, it will be RC. Second one, it will be 2R times 2C, which is 4RC. For the third one, it is 2R times C, which is 2RC. So we got the time constant for each circuit. Then it's asking us identify the circuit which requires the most time to fully charge the capacitor. So more the time constant, more will be the time required to charge the capacitor. So highest time constant is for circuit B. That means circuit B takes most time to fully charge the capacitor.